Let us quickly walk through linear regression, assumptions in linear regression, types of linear regression, as well as applications of linear regression. Why this video is important? Because most of the interview questions starts with a linear regression only. So they may ask you to explain about linear regression, or sometimes we can also come across the questions like assumptions in linear regression, right? So generally what I have seen is people find it to be really difficult to answer the questions about assumptions in linear regression. So I will guide you how to answer this question in an interview. So first of all, let's try to understand what is linear regression. Though I have done several videos on it, it is a quick go through about linear regression, right? So what is meant by linear regression? So the first point what we need to answer about is like it is a supervised machine learning model. So what is meant by supervised machine learning model? Which means that it works on the labeled data. What is meant by labeled data? There is always an output. So technically, we call it as dependent variable, right? And another point is that linear regression is a regression-based model. What is meant by regression? The dependent variable is numerical. Right? So these two are the first points that should come to your mind. What is linear regression? Linear regression is a supervised machine learning model where the dependent variable is numerical. And what we do with linear regression model? We try to derive mathematical relationship, right? Mathematical relationship between dependent variable and independent variables. Now you can see here, I'm writing dependent variable as singular and independent variables as plural. What does that indicate? There can always be only one dependent variable and there can be any number of independent variables. Based upon the type of dependent variable, we call it as regression or classification. If the dependent variable is numerical, we call it as regression. If the dependent variable is categorical, then we call it as classification. But linear regression is a supervised regression-based model. Hope it is clear. So let's start with an example to understand it better. So let's take a day-to-day example, right? So most of you may be having the habit of consuming coffee or tea, right? Imagine tracking your coffee consumption. How many cups of coffee you consume as well as the number of hours of sleep or the number of cups of coffee, the total cost of coffee, right? So let's take that example. Number of cups of coffee as well as the cost of it. So you can see here cups of coffee, I'm considering it in x-axis, which is basically the independent variable here. And I'm trying to find out the cost, which is basically dependent variable, which we are taking it in y-axis. So what happens here? 1 cup, there could be a cost, 2 cups, 3 cups, right? So you can see that it's forming a straight line. So when I try to derive the relationship between independent variable and dependent variable, I would be ending up with an equation which is called as y is equal to mx plus c. What is x? Independent variable. What is y? Dependent variable. What is m? Slope, which is nothing but how much does the dependent variable change when there is a unit change in independent variable. C is y-intercept, right? Y-intercept, which is nothing but the value of dependent variable when independent variable is equal to 0. Hope it is clear. So let's now try to understand. This is how we will be getting it, right? Let's now try to understand about the types of linear regression. So simple linear regression, there can be only one independent variable and one dependent variable. This is where I told you y is equal to mx plus c. Multiple linear regression, more than one independent variable. x1, x2, x3, there can be any number of independent variables and one dependent variable. So y is equal to m1 x1 plus m2 x2 up to mn xn plus c. Remember, there can be only one intercept. Do not assume that as there are n independent variables, there is going to be n intercept. There can be only one intercept, right? All the time there can be one intercept. And also in the interviews, what I have seen most of the time, people answer C as constant. C is not a constant. It is y-intercept. So if there are more than one independent variables and one dependent variable, then it is called as multiple linear regression. Very simple. So based upon the experience, if I try to predict the salary, then it is simple linear regression. Experience is the independent variable. Predicting salary, that is the dependent variable. Only one independent variable. Multiple linear regression, there can be any number of independent variables. So let me consider an example. Based upon the area of land or house and the number of bedrooms, age of house, location of house, type of house, I'm predicting the price of house. This is multiple linear regression. Price is the dependent variable, area, number of bedrooms, age of house, location, type of house or independent variables. So what I could see from the analytics of my video is that more than 60% of the people are watching the video without subscribing the channel. So your subscription means a lot to me. So please subscribe the channel. And also, if you really like the concept and the way of explanation, hit like and proceed with that. So now you can see something here. You can see y is increasing with x, right? So let us now try to understand about positive linear relationship. So let's take a simple example. Based upon the temperature, I'm trying to predict maybe the price of ice cream. Or based upon the temperature, let me predict the ice cream sales. So whenever the temperature increases, ice cream sales increases. Whenever the temperature decreases, the ice cream sales also may increase. So you can see both are changing in the same direction, which is called as positive linear relationship. Y is increasing with x. So this is positive linear relationship, positive correlation. Negative linear relationship, let's take another example. Based upon the temperature, I am predicting the number of flu cases. So whenever the temperature reduces, what happens to the number of flu cases? Definitely it will increase. So you can see that both are changing in different direction, opposite direction. So when x is increasing, y is decreasing, which is called as negative linear relationship or negative correlation. Now, this is the part I was talking about, general interview questions, right? What are the assumptions of linear regression? So mostly people struggle to answer this question. So I will make it very simple. The first assumption, linearity. What is meant by linearity? The relationship between independent and dependent variable is linear. For example, 1, y is 5, 2, it is 10, 3, it is 15. So if you see that it is looking linear. When it is not linear, for example, I'm writing 5, 10.4, 15.9. So now you can see that it is not linear. So in this particular case, linear regression may not work well. So the linear regression model work well when the relationship between the independent variable and the dependent variable is linear, right? So that's the first point. One more thing, I want to know whether the data is linear or not. How I can do that? I can go ahead with a scatter plot or pair plots, right? So most probably scatter plot will give us the idea about it. So what is the purpose of scatter plot? We try to study whether the change in the dependent variable is proportional to the change in the independent variable. So let me also give you an example, predicting house prices. When the number of bedrooms increases, the price also will increase, right? The second one, independence. So observations in the data set are independent of each other. So what do we mean by this? One observation should not influence another observation. So we can say randomization helps ensure independence. For example, customer purchase history. One customer's purchase should not affect another's. The third one, homoscedasticity. So what does this means? The variance of error should always be constant, right? Variance of the error, which means that spread of the error should be consistent. So how we can identify, how we can detect it? With the help of the residual plot. So for example, I'm predicting car mileage. The variance of error should be constant across all the car models. The fourth one is normality. Error terms should be normally distributed. So we can detect it using histograms or QQ, quantile plots. So now example, exam scores. So we want the error term should be normally distributed. We know the meaning of normal distribution, right? Gaussian distribution. The next one is about multicollinearity. No multicollinearity. What is meant by that? Might be I'm trying to predict the sales. So ad spend and promotion should not be highly correlated, right? So here the correlation matrices or variance inflation factor can detect this, right? You can see like VIF or correlation matrix. We generally find out the correlation that will basically help us to identify that. So in another video, we have discussed like displacement, weight, acceleration, right? There was very good correlation among the independent variables. In such cases also, it is not really a good idea to proceed with linear regression. So let me tell you all the assumptions. The data should be linear. The second one is about independence. Observation should be independent of each other. Third one, homoscedasticity. Variance of error should be constant. Fourth one, normality. Error terms should be normally distributed. Fifth one, there should not be any multicollinearity. So now I want to know whether my model is good or not. How I can find out that? You can see R square. Already I have posted one video about R square. If you want, you can look into that. Also adjusted R square. I would be giving the links in the description. R square, adjusted R square. There are also other metrics like mean square error, root mean square error, mean absolute error, and so on. So how the value of R square should be? We want the R square value to be close to 1. What this R square indicates? It tells us about the percentage of variance explained by the model. Percentage of variance explained by the model. So we always want R square value close to 1. Then we can say that the model is a good model. Okay. So now we know what is linear regression and whether it is supervised or unsupervised, what are the types of linear regression, positive correlation, negative correlation, what are the assumptions, what are the metrics to identify or to test the model. Now let's discuss about the applications of linear regression model. So the predictive modeling. Say like I want to predict the price, right? Finance, marketing or stock price, right? So there I can use this, right? All the domains I can tell you, even with the logistics, supply chain, healthcare, right? So whenever the data is structured, so most probably we would be using this, right? So the next one is about, say, you can see some example, predicting sales, right? When we try to predict the sales based upon the advertising spending or forecasting stock prices. The second one, as we have discussed already, to find out the relationship, right? For example, based upon the number of hours of study, how much, right, how much marks the student can get, right? So it is basically to get the relationship. Causal inference. We can also see the impact of independent variables on the dependent variable. Say effect of education level on income, right? Again, like, or we try to study how pollution affects health outcomes, right? Then model interpretability. So what do we mean by that? Linear regression is basically simple and interpretable when you compare with all the other decision tree or bagging or boosting models, right? Because it is very simple and we can quickly get insights about it. Then variable selection. If you see there, like a like a real estate, for example, I want to identify the key factors like a location or size, right? The stepwise regression will definitely help me to pick the most relevant variable, right? Which attributes are important? Easily I can pick that. Okay, we are talking about the advantages or the applications of linear regression. There could be always limitations too, right? Disadvantages. Yes. So let's now discuss that. The first one is assumption of linearity. In case if my data is non-linear, I'm trying to predict the relationship between house size as well as the price. Sorry, I'm trying to predict the price based upon the house size, but it is not linear. Then the linear regression may fail. So in such case, I'm supposed to go ahead with other machine learning models. We will be discussing in the upcoming videos. And the second one is like it is very sensitive to outliers. For example, I'm trying to analyze employee salary. One extremely high salary may be distorting the result of it. So outliers may affect the model's accuracy. The third one, assumption of independence. Say, for example, I'm trying to predict the price or stock price. So stock prices often depend upon the previous values, right? So linear regression assumes independence, which is not actually true here. The fourth one, multicollinearity. We are trying to predict sales with ad spend as well as promotions. In case if ad spend and promotions are highly correlated, it is really hard to tell individual impact. So multicollinearity inflates standard errors and complicates interpretation. The fifth one is about it is limited to linear relationships. Linear regression is limited to modeling linear relationship between the variables. Say, for example, customer satisfaction, right? Customer satisfaction may depend upon the complex factors. So linear regression cannot capture all non-linear interactions without a transformation of the data. The last one, overfitting. Using many predictors, I can predict or forecast the sales. Too many predictors can fit the training data too well. This may lead to poor performance when I go ahead with the new data. Though linear regression model may not be widely used in the industry, it is very important. One reason is that it is basic to understand all the other models. And another one is that it is really going to be the most important interview question. So you cannot skip it at any cost. Once again, let me repeat what I have told in mid of the video. Please subscribe the channel and watch the videos further. That could be, really motivate the people like us. Thank you so much. If you have any questions, please post it here.